So, like Corinne mentioned, I'm an assistant professor of plant pathology. So my area of specialty is in, diseases of plants. So I study diseases, particularly of crops that we grow here in the Salinas Valley. Okay, so what we're gonna go through today would be recognize that, again, plants are impacted by plant biotic and abiotic stressors or threats. We're gonna go through that, and I'll explain what that means. Understand the significance of the effects of those stressors on plants, and learn about the importance of the safe use of pesticides, because yes, it is, we still depend on and need them. Are the lights okay? Can folks see the slides? So what setting up is in the back. All right, so we're gonna start just talking about how plants are impacted by those stressors. So it's not a secret that we have many challenges in the current century, and these challenges are even gonna be bigger in the future. But we know that we have a growing population. We not only have a growing population, but we have still nowadays, despite of all the advancements that we've had in science and technology and societal and political advances, we still have people that do not have enough food to eat, or even if they have enough food, they don't have food that is nutritious enough. There is a misconception that only people in Africa are malnourished, right? Because they don't have enough food. Yet we here in the United States, we have people that do not have enough nutritious food, especially folks that live in our tribal communities, because they live in the food deserts, where the only sources of food that they have are gas stations. So if you think about, if you were grocery shopping at your gas station, you have a very limited amount of types of foods that you can access, and primarily this would come in cans, highly produced or manufactured forms of foods, not necessarily fresh food. And one of on top of that is social disparity, is that we also have environmental constraints. We have limited access to water, we have limited access to fertile soils, or arable land, we have salinization of land, habitat degradation, and climate change. If throughout the presentation there is any jargon or any words that you do not understand, please let me know. And I tried my best, but again, I was on a plane and a little distracted, so I might have missed a few jargon terms. But just does anybody know what arable land means? Yeah, right. So you cannot grow crops everywhere, wherever you want, right? So you might, when you drive through Salinas, you see all those very lush and green and growing lettuce, and you plant lettuce in your backyard, it doesn't look exactly the same, right? Because mostly, especially if you live here in Marina, your soil is actually sand. So that is not necessarily the most conducive soil for you to grow plants. We have actually in this region a huge problem with salinization of the soil, because we have water intrusion from the ocean that is coming down underground, and that salt is actually, once it starts mixing with the soil, it actually becomes toxic for the plant. So there are several issues on top of the human-driven. We have other ones that we have less control on. So again, the grand challenge is that we're currently about 7.5 billion humans on Earth. We're gonna be reaching 9 billion is expected by 2050, which 2050 is not that far. And we're gonna be adding 2 billion people. And by adding 2 billion people, we would have to actually not even double, but we actually have to increase the amount of food that we produce currently by 70%. And you would think, well, we have a lot of advancement, right? We are better. We're not growing food the same way that our ancestors used to. We have gotten better. We now have technology. We have machines, but we don't have more land. We don't have more planets, right, to move. So we are actually have to double the amount of food production without adding more land. And on top of that, just 2 billion people would also need houses and parks and roads and schools. So the space would be even more and more constrained. So the main challenge that we have that we need to grow more food with less resources. So how do we go about that? Any thoughts? How can we accomplish growing or producing more food and also more nutritious food, perhaps with less resources?
Initial thought would be to build up. If we can't build out, then you're going to need to scaffold, build upwards. I've seen that in science fiction.
Correct. No, absolutely. I mean, going that we have used that model, right? We went from everybody has a single house to building apartment complexes, right? That everybody is on top of each other. So be more efficient with how we grow food, right? What else?
The speed of how fast the plant grows.
Can we actually, push those plants and actually, encourage them in a way, incentivize them to grow faster and grow more? Yes.
That if we move to less meat and more plant-based, does that help our food?
So that is, you saw it here in the icon. So 70% is actually, that's a great point. So the point is like, well, maybe we eat more plant-based products and less animal-based. That would be a good way to accomplish that. This 70% that is there is the average. It is expected that because we are not growing the same all worldwide, right? There are specific countries that are growing at a faster pace. In some cultures, especially that have more habits of consuming more meat, animal-based products. So the 70% is the average because we actually have to double the amount of animal production that we have. So we would need to produce 100% more livestock that we produce not today to be able to fulfill the needs of in the future. You have a question?
Well,
Yeah.
I'm a little confused about that because if the population goes to 25%, why do we need 70% more food?
Correct, because also the people where the populations are growing, also the societal our rankings, the groups that are growing have more access to different resources. So now we not only have to produce enough meat to fulfill the needs of the United States, but now our growers fulfill many of the needs of other countries because they are big exporters. Because now being in agriculture, being a successful producer doesn't mean actually to fulfill your local needs. That's often actually even less value because you make more by actually selling it away. Yes.
But we also need to produce more yield, right?
Absolutely.
So less waste, less
Absolutely.
wastage, and also maybe more rotation of crops out in the season, so more crops grown in one season.
And that is so that and that is part of one of the constraints that we have. Not all crops we could grow multiple crops in a year. In not all places we could grow multiple crops in a year. We are all of you are in this area, right? Yes. So we are spoiled because we could actually have agriculture all year round. But maybe many of you have not been only here. You've been in other parts of the country, and you know that that's not a case. If you're in the Midwest, you know that you only have 8 months of a season because you also have a very harsh winter where you cannot grow absolutely nothing outside. And there are other places where it's the opposite. It actually gets so hot that the crops cannot survive outside. So it is a limitation in this idea that we have that we can just always produce more food is it's a utopical idea because that's actually not the case. Because on top of that, we're also dealing with, again, environmental challenges that we have. So I think that, yes, being more efficient in how we grow food, being more efficient in how we educate consumers also. There is so much food that is wasted, not only on the farm, so food that we don't harvest, but actually the food that is not, that is wasted at the supermarket, food that is not purchased, or food that even we purchased and we wasted it at home. right? Because you buy your strawberries and you let them sit for a while, and by the time that you go eat them, they're all moldy, and then you throw it away, right? And those strawberries, even though you're not consuming them, you already pay for them. They require water, they require inputs, they require space. So there is much, we could be much better in how we educate our population and how to be better consumers, but also be more willing and understanding of the challenges that we're experiencing. All right, so some of the ways that we have accomplished this in the past or throughout the many years and have allowed us to be successful in the agriculture sector has been by improving growth potential. So this is how we can make plants more efficient at growing. So if you look here, this example, this is the wild ancestor of corn. If the name is tercine, and it's a crop that a plant that the indigenous people in Mexico is a wild species that is native of Mexico used to consume. But if you look in the picture on the right, this is the modern corn. What are some differences that you observe in the architecture of the plant? Do they look exactly the same?
Fewer, bigger leaves.
Fewer, bigger leaves. And what else?
Multiple flowers.
Multiple flowers.
The teosinte.
Uh-huh.
Bigger horn.
Bigger ears. Yes, absolutely. Look at what the comparison with a coin. This is how the teosinte grains were much, very, very, very smaller compared to the coin, right? Versus a current ear. And this has been accomplished through just selection, just by selecting. This is not any biotechnology or transgenic approaches, just by selecting the plants that grow more every year and hybridizing them or crossing them against each other. So they start seeing, well, if you have plants that produce less or fewer leaves, then those resources, so the plants function, they have a budget. So there is an amount of energy that they can produce. Remember, plants produce their own food by absorbing the light from solar light, going through photosynthesis, and on top of that, they have resources in their surrounding area that they consume through their roots. In that budget, they have to partition between growth and defense. So you can think about just like when you are sick, you're not gonna go run that race, right? Because you have an amount of energy. You have to use it, or do I want to recover, or do I want to invest my energy in running the race? The same for the plant. Do I want to invest all the resources into growing, or do I want to invest my resources into defense? So by selecting varieties, and we've done this with every single crop that we grow. We have another one. What is unique of bananas compared to other fruit crops? You're back.
They're all close to each other.
They're close to each other. Are you a student? That's why you knew that. What else is even more besides the fact that yes, they are completely identical. Why they are identical? One variety, and why is, well, the reason of that is because actually, spoiler alert, is because of plant disease. But what is also unique? Why are bananas such a unique food item that we give kids and we use for food, baby food products and a bunch of other stuff? Why make it so easy to deal with that?
Naturally packaged.
They are naturally packaged, yeah. What happened when you open a banana? There are no seeds. There are no seeds. The wild ancestor of bananas used to have seeds, and we start selecting actually the varieties that were producing less seeds up until the point that we only have one variety that we have to clone it to be able to reproduce it. So we make decisions along the way that obviously affect the way that plants are, but we make those decisions based on what we want, not necessarily what is best for the plant, right? Inputs, of course, you add in fertilizers, add in water, add in pesticides if needed. So we have the ability now to have in the market, whenever we need something, we go and get it, right? You have a headache, you go get a pill. If you have, you cannot sleep, you go get a pill. What's the same is in agriculture. Whatever we need, we have a market that is providing those supplies to support the production. Yeah.
Is that the case, so back to the bananas, is that the case with all varieties, like the cuadrado, and like the plátano, like, are all of them plants?
So
or
the
is it
plátano-
just the guineo?
So the banana, the Cavendish, the banana, the Musa sativa is the species of banana. It's only one variety, it's called Cavendish. And was selected because there was, again, there was a plant disease that wiped out all the production of bananas of the previous varieties that we used to have that actually tasted better. For all of you who have traveled outside of the US and have tried bananas elsewhere, you know what I'm talking about, right? Like the bananas that you buy at Target are not the best. Because we actually, if you think about it, we don't grow bananas here. We have to grow them in the tropic, harvest them when they're green, which means they have not actually accumulated or produced the sugars that actually are naturally produced by the plant. And then we actually apply products that stimulate that production of the or ripeness of the fruit once they are away from the plant. So they are not longer getting those resources from the plant. But so the plátanos and the guineos and all these other more less developed relatives of the banana are not grown clonally in the same way as banana, just because they're the standards of quality are not as uniform for banana. In the banana, again, this is not a talk about banana. I would love to talk more about it. But there is actually, when the market sets the price for bananas, just like lettuce, FYI, they have to have a specific size, a specific coloration, the number of spots. Like people go to the market and they, oh, it's too brown, right? Or it has too many spots, I'm not gonna get it. Those are actually market traits that the producers have to deal with. So they've been actually selecting for the most uniform varieties. And then of course, this idea of closing the yield gap. So the yield gap means how much this corn, we have allowed the modern corn to produce this much, right? This big ear, but how much actually we are getting out or consuming from this corn based on the fact and how much we're losing in the field. So if you think about this is an example of corn that has been in which they use insecticides and corn in which they didn't use insecticides to control pests that were munching or chewing on that corn. So it is a combination. So how do we grow more food with less? We need to improve the genetics of the plants to make them more efficient. We actually need to add inputs because the plants cannot longer produce how much we want and what we want the plants to produce. And then close the yield gap, and not only the yield gap in the field, but also the yield gap after we harvest the plant. So some of the factors that limit plant production, of course, are inadequate moisture. So if you don't water your plants are gonna wilt, right? So the same is for food crops. Lack of nutrients. If you don't have, you might have plants at home, and if you don't fertilize them, they might survive, but they're not, they don't look the same as the botanical garden or even like Home Depot when you go there, right? It's like, why my plant sucks? Like it doesn't grow. Well, because you have it in a corner where there's no light, you never water them, and on top of that, you don't give them the food. So there is a lot of reason, and plants have the ability to produce their own food, but to a certain point, the rest has to be supplemented. Suboptimal conditions, like including salinity, low pH, we talked about that with the water nutrition, pests, including insects and nematodes, also pathogens, including bacteria, fungi, and viruses, and of course, suboptimal temperatures related to climate change. So we don't have a solution for the last one, right? If it's too hot, we cannot just set up an AC to cool the plants down. If it's too cold, we cannot just wrap plants in blankets. So that one is a tricky one. But for the other ones, we have inputs. And that has been the model that was developed in what was called the Green Revolution of Agriculture in the 1970s, when people start realizing that a better way to produce more food was by actually not just relying on how much the plants can produce, but actually supplementing that growth by adding whatever they need. If they need water because the plants are not drought tolerant, let's add them water. If they are being attacked by a pest, let's add insecticide. If they're being attacked by a pathogen, let's add a pesticide. If they're not growing because they're in a yucky soil that is not very fertile, let's add fertilizer so they can actually, we are just spoon feeding them literally what they need. So all these approaches or inputs that are in this blue category represent what is called synthetic inputs. So fertilizers, any kind of product that you're adding, and usually those are the ones that you go to Home Depot, to Walmart, and they are broadly accessible. Anybody can buy them. They are also in this lower category. These are what are called pesticides. And these are products that are specifically, the main goal of using them is to control a particular pest. They are pesticides that are actually quite accessible. You could purchase them at Walmart, Home Depot. Anybody can apply. There's a lot of controversy about Roundup, but everybody can actually go and purchase Roundup without even being an adult or without being actually a producer. But there are also some products that have a lot more restriction, not because they are more dangerous, but because they are specifically dedicated for commercial production. And when you're a grower, unlike when you are a private citizen that is growing a plant in your backyard, you cannot just spray whatever the heck you want. You actually need to have, go through several steps, and you need to have the equivalent of a pharmacist that has to write a prescription to say, this is how much you can apply, this is when you can apply it. And I don't know how many of you have been in fields that have been sprayed, but they put a sign, right, telling, like, you cannot walk into the field because it was sprayed. So those, they're called pest control advisors. Those are the ones that set up those regulations based on the labels that the product and regulations that the products have. All right. Are we good so far between, okay, so biotic means everything that is alive, and we're gonna go through some of the examples now. Insects, weeds, diseases. So those are factors or agents that are attacking or impacting negatively the plant. And then abiotics are the ones that we don't have much control. Floating, drought, heat, cold, temperatures, etc. And so we mostly use pesticides towards biotic, to control biotic factors. Yes?
Just for clarification, when you're talking about pesticides, are you talking about herbicides as well?
Herbicide, that's a good question. So we're gonna go through the definition of pesticides in just a little bit. But yes, so in the broader, so in agriculture, in agriculture sciences, just like in any other field, we love to silo things. Because we cannot work together, right? We always have to have people working in isolation. So we have, for insects, we have insecticides. For weeds, we have herbicides. For fungi, we have fungicides, and so on and so forth. But they all belong within this category of being pests, and being pests that are affecting plants, and the products are in the category of being pesticides that are used to reduce the effect of those pests. So why is it important to actually use them, or what do these attackers do to our plant? So we know that pests in general interfere with human and animal activities, right? Many of you might have experienced any of these situations, not only with pests, but also with diseases or microbes that affect the way that we feel, our ability to perform our activities, or even determine whether we are actually alive or not. And you might be wondering what, I mean, so what, why are you showing us these like gross pictures? Because the same happened to plants. The plants are also being attacked by insects, not the same one, because mosquitoes have evolved to actually only eat blood, but they are insects that we are not perhaps aware of them, but they have evolved to eat the equivalent of the blood of the plants. Or they have evolved to just munch on the plants, right? So we have different insects that are specialized in consuming different organs or different parts of the plants, and have different consequences, whether it is completely cosmetic. You know, growing up, I grew up in Costa Rica, and it was very common to have this fruit around falling from the trees, and people would be just like, oh my God, just get rid of the larvae that is in that fruit and just eat it. It's not gonna kill you. But here we have a completely different. I promise you, my kid is not gonna. Not because just because he's growing in an environment that he is already being, indirectly being taught that, bugs are, right, and microbes, and being more aware of this kind of potential things that can have a negative impact. But in some cases, again, the only effect that this insect or pest have is completely cosmetic. It do not affect the quality, the nutritional quality of the product, and they do not pose a harm to humans. But if we want to get rid of them, we would have to spray a chemical pesticide or a pesticide to get rid of them. The same happened with plants. Plants get sick the same way with us. And the difference is that we cannot put masks on them, right? And often you probably remember when we were socially distant, right? So we have to keep distance, so we were not passing microbes from one to another, or we were wearing masks. Well, go to a field and see how close those plants are growing next to each other, right? There is no way to actually control the exchange of these microbes in the field. And the microbes also can affect plants in a different way, in whether it is completely cosmetic, like in the case of citrus. This is citrus greening, which is a huge problem currently in the United States. It's threatening the production of citrus in the country. Stem rust, which is one of the main pathogens and diseases that threaten the food security in general, because it affects nearly all varieties of wheat. So whoever likes bread or any baking goods, this is your worst enemy. And again, other stuff, this is actually a banana plant. So a banana plant that is infected by a bacteria, and when you cut the stem, the banana plant, it has all these pipes to move water through the stem. And this bacteria has the capacity to clog those pipes. So all that like snot that you see coming out is actually bacteria ooze, or the bacteria that is actually clogging the water pipes, so that the plant cannot actually consume the water that is pumping from the soil, and the plant dies. And this, who wants to guess what this is? Bigger than a walnut, smaller than a melon. Not a fruit. A potato. It's a potato. So it is infected with a bacteria that actually rots the inside of the potato, but outside you don't see it. So what is up to you cut it that is completely rotted inside, and I promise you, you have never experienced smell like that. It is the worst. Yes.
Now, are these new to the United States, or are these things that
that are kind of normal, but because we didn't mass those together.
Yeah, so that's a good question, whether these are native and current issues or have they been introduced. It's a combination, because also many of those crops, some of these crops we do not grow in the US. For example, we don't grow bananas, but guess what? At Costco the other day, I saw banana plants being sold, right? And so they could be introduced, and it's not necessarily introduced in a biotourism way, it's introduced in plant materials. And sometimes if you buy a plant from Costco that happens to have that bacteria, but there are not enough bananas in the area, it's not gonna make it. The environment is not adapted to the environment, it's not, not gonna survive. So eventually they would die off. The problem is when they are introduced in areas, for example, citrus greening was introduced to the United States in orange or citrus materials from a citrus producing area elsewhere into Florida, where there is a bunch of citrus. So the pathogen eventually evolved to adapt to the Florida condition. So some of those also are, this is papaya ring spot virus. So it's these ring spots. And it actually is a disease that was only a problem in Hawaii, and where Hawaii is where we in the United States we produce almost 100% of the papaya that is consumed, other than that is consumed in United States territory, is produced in the Hawaii. And this virus is transmitted by insects and almost wiped out the production of papaya in Hawaii, but it wasn't a problem anywhere else. So it depends. So sometimes we have kind of like the COVID light that is like a pandemic kind of situation, because guess what? We actually had pandemics, we have outbreaks, we have all this kind of stuff with plants way before we actually learn about them through COVID. So it happens, it's a huge problem in agriculture. So worldwide, 40% of all the crops are lost due to pests and diseases. So meanwhile, we are trying to select for plants that grow more, right? And give them more water, and give them more food, and give them more better resources, making them more efficient at growing upward, being more efficient at using the space, right? And then you get a pest that comes and wipes out your production. So that is the reason why this is such a big deal, and it's important to control. Just in the case of during my talk, I'm not gonna talk about weeds, just because my area expertise is more on diseases and pests, and I did not have access to the internet on my flight back yesterday, so I couldn't pull pictures of weeds. But actually, weeds are also a main problem, and especially because when we talk about weeds, those are plants that are growing in the surrounding area, and they are just growing because you are actually giving other plants the ability to grow. You're giving them water, you're giving them food, you're giving them the right conditions. So they are not like bad plants. They are just taking advantage of the conditions. The problem is that we don't want them, because they're also taking away resources from the main crop that we want to grow in there. So pests and diseases, again, so plants account for 80% of the human diet in average. In healthy plants, of course, if you think about plants that look like this, you might not think that they're gonna make you feel very healthy, right? You might not even eat them. So healthy plants produce not only more yield, but also more nutritious products. Diseases harm the plants and their ability to perform their desired function. And what we don't often think is that we don't only grow plants for food. We also grow them for feed, for fuel, or even for fiber. So we grow plants for actually making clothes, making blankets, making a bunch of other stuff. We grow a ton of field crops like corn and soybean to produce fuel or ethanol that actually can support different, or can be used as a source of energy. And of course, to feed the animals that then later we're gonna eat, we need to feed them first, right? So all the crops that we grow that are not even for human consumption, but we grow a ton of field crops and grains, particularly to feed this livestock. So when disease strikes, disease fall. I know I'm running out of time, Corin, am I good?
You're good. We love
Okay,
your
'cause- so I'm just gonna give you very quickly 4 examples of major diseases. We already talked about bananas, so that was one that I didn't include, but 4 examples of major epidemics of plant diseases that have huge impacts in human culture. So how long do you think plant diseases have been around? Millennia. So don't know how many of you are have read the Bible or have heard, but there are paragraphs, and it's one of those punishments, right? Or one of those there's text that says that you would experience blast or blight or mildew. Those are terms of diseases that are actually in the Bible. They are in the hieroglyphics that actually show diseases killing the plants. And even in the Roman Empire, they have this god called Rovigo, and Rovigo was the god of rust. So rust is this disease. And Rovigo, in the Roman Empire, they actually used to sacrifice a red animal, a dog, a fox, in actually offering it to Rovigo. So Rovigo would take the life of the animal instead of taking the food away. And so this is a illustration of people they're not killing the dogs anymore, but they're still celebrating Rovigalia, which is that festival that they used to have. Okay, how many of you know of the Salem witch trials? You've seen the movie probably, right? So, how many of you know the real reason?
Oh, yeah,
You're excited, go ahead.
it was, a fungus on the wheat, or,
Close.
but
Close,
but anyway, it caused them to hallucinate, I believe.
You should come and teach this class because you're absolutely right. So there is ergot rye was a disease that was infected. Rye was the main product that they were growing. So this is how rye should look, yellow and green. And then when it's infected with this pathogen, the grains turn black. And so when they thought that these women were taken or were under the effect of this the evil or being witches, they actually were not. They were just high because this pathogen produces an alkaloid that is actually accumulates in the grain. But how many of you know, or can you guess why only the women? Why we're not the Salem wizards?
They were the ones that, women made bread.
The men were working in the field harvesting, but they were outside. So they were not as exposed, but the women were actually working in the mills and making the bread. So they were actually in direct contact with this toxin. All right, so how many of you identified as Irish or have Irish descent?
Only on St. Patrick's Day.
Yeah. Okay, do you know, does anybody know why there was a large number of Irish immigrants coming in the 1800s to the US? Okay. Irish potato famine, right? So there was a disease of potatoes. The potatoes were the main staple crop in Ireland. They were growing the same potatoes in FYI, if you don't know, a potato is actually is the seed. So the tubers that we eat is what you use actually to plant a potato. It's not the real seed of the plant. The plant actually, if you let it grow, would produce flowers and fruit with very, very tiny fruit seeds. But you actually, if you plant a potato, you actually would get a plant that now would produce about 20 more potatoes. So it's a good deal, right? And now you get 21 at least. So the growers were saving their own seed, their own tubers. They kept saving the rotten potatoes and they kept planting them, hoping that a potato would come out. So that actually in about 5 years caused almost the entire production of potatoes in Ireland to disappear. And that led to over 1 million people died of starvation, not having enough food, because these were people that actually depend heavily on potato production for their survival, and then many immigrated here. All right, last one. How many of you know why the British drink tea? You probably already got a sense, right? One that you didn't know. Nobody?
Something happened to their coffee.
You're absolutely right. So coffee rock. Sri Lanka, what is Ceylon, or what is today Sri Lanka, used to be a colony of the British kingdom. And so they used to actually grow all the food in Sri Lanka and Ceylon, and then bring it to the mainland. So believe it or not, for a while, the UK was one of the main exporters and producers of coffee, because they were growing it elsewhere. And then this disease hit Ceylon. It's a disease that actually affects the leaves, so the plants set the fruit. So if you don't know coffee, these are the coffee berries the plant produces. You have to wash this, get rid of all the pulp, and it's actually the bean that is inside what we actually fry. But what you can see here, this disease hits, and the plant loses all the leaves. So if the plant loses the leaf, the beans don't ripe, so they don't turn red, so they remain green or actually fall off the plant. So in 15 years, there was no coffee plants in Sri Lanka or Ceylon. So, but they noticed that they have introduced some plants from China, tea plants, that were not being affected. And so they quickly realized that that was perhaps the solution. And they actually, there is evidence when they were actually making sure that the queen or whoever was in power at the time would actually drink tea in public. So that became this idea that is a part of the British culture and identity, even though it wasn't up until before this plant disease hit. All right, so just FYI, unfortunately, these are not from the past, but these are all from the present. These are diseases that are actually threatening many of our favorite crops. If you like to eat, there are many yummy foods that are here, but there also, if you like to drink, including beer and wine, there are crops that are affecting the crops that we use for this product. Okay. Closer to home, I'm not gonna give you an overview of why agriculture is important here. You all know that, but we're known as the salad bowl, and we produce all these numbers that you see is all the percentages that we produce for nationwide. So 90% of all the artichokes in the country are grown in Castroville and in the area, and so on and so forth. It's estimated that one out of five households in Monterey County actually rely 100% on agriculture industry as a main source of income. Yes?
So is the 9 billion for the Salinas Valley, for Monterey
Correct.
County, for?
So the Salinas Valley.
Salinas Valley.
Okay, so I don't know how many of you know who Cardi B is. Maybe the folks in the back. I'm not trying to age anybody, but it's a famous rapper and somebody who became quite loud this year, complaining why lettuce prices were so high. And of all the things that a famous rich person could complain about, she was complaining that lettuce was $7. Like if she couldn't afford it. But anyway, it causes all these trends and people complaining about lettuce. And this was in the spring, so it was mostly our lettuce that at the end of the season here in the Salinas Valley. What Cardi, and so she was blaming inflation, she was blaming Biden and a bunch of other reasons. What she didn't know is that there was actually a shortage of lettuce in our region because, so if you're not familiar with lettuce production, we grow lettuce here from about March up until December. And then in November or October, November, the industry starts moving to Yuma because it gets too cold here. And then starting February, January, February, they start moving back up here to have the first crop planted in March, etc. So there is always an all year round production supply. But the production that we grew our fall production last year was really bad, and there was a shortage, and we haven't started in Yuma, harvesting in Yuma. So for a while, there was not enough lettuce. And what happened when there is not enough of something, the price go up, right? So normally, box with 35 heads of lettuce cost about it's like 30 cents a head. And during this time, there were the box of lettuce each, so it was costing about $50. So it was more than $1 that the growers were being paid when normally the max that they get is like 30 cents for a head of lettuce. And then you go and pay 3 more times at the supermarket. Right? But what the main reason that was causing that shortage, guess what? Anybody wants to give? There were some diseases. And Cardi didn't know that in our region, many of you maybe have people that work in the industry or have heard terms like INSP. So INSP is the main virus that affects lettuce. And it's one of those that it actually doesn't kill the plant. It doesn't even influence that much how the plant, you can still harvest because the plant is a virus that is transmitted by this tiny little insect. So that when the insect feeds on a plant, delivers the virus. And then the virus causes this necrosis on the leaves. But the main problem is actually the necrosis on the veins. Because how many of you have seen lettuce being harvested? You know, they send the crews with this like lettuce knife and they chop all the outer leaves, they leave a bunch of the green in the field because they can't get rid of all that stuff. So they harvest a plant that is like this and they end up with a tiny little plant because they get rid of all the yucky stuff. But the problem is that you cannot actually see the inside. So there's some growers that have to because they actually have harvest what they saw that it was good, they ship it, and by the time that it arrived to the supermarket, it was looking like this. So there were some fines and some law, some suits that they have to deal with in that regard. But the water virus again is like COVID. It's a systemic virus that travels throughout the plant and it affects the quality of the plant. Yes.
So when they trim the damaged leaves off, do they leave it in the field and then we affect?
Not the great question. So the question is, so if they come and get rid of all these leaves and leave it in the field, could it affect the next crop? It would not affect the next crop for this particular disease. It would not affect the next crop because again, it's a virus that would when the plant material dies off, the virus would die with the plant. The problem is throughout the season, if you have an infected plant, now the threats can come, feed on an infected plant and move here. The problem that with the situation that you just described with again is kind of beyond of probably why you want to learn this stuff, right? We're in this session, but so the problem is that those leaves that are on the ground, they have some threads. They are carrying the virus, and then when the lettuce start dying off in the field, they move. And they go and find another crop. They don't infect the other crop, but it allows them to survive. And the virus can also host the virus. But we don't really pay attention to the weeds because we don't care about them. but the virus survives in those wheat species while all the lettuce, it's one of the questions, how is this virus surviving? If we move all the lettuce production to Yuma, the virus survives in this phase for all this winter months. When the production comes back, the thrips move from the wheat into the lettuce and carry the virus.
JP, you have to then sterilize the soil so that,
The virus doesn't survive in the soil, the virus only survives in live material.
so you have to make sure all the residue is gone,
So-
and not composting in the soil.
So what they do is once they harvest, they send the tractors and very quickly integrate the leaves into the soil.
So even that would be okay.
That would be okay.
Question, you talked about a lot of different pests, and you talked about the ergot on the, what happens to humans when we eat some of these pests? Is it that we are psychologically so appalled by looking at food that it looks bad, or do we get sick from some of these pests as well?
The first, we are so over aware and terrified of microbes and pests in general that and I'll talk briefly about this because there are certain crops. How many of you have heard probably of food safety, right? Food safety on lettuce is a huge problem. I did my entire PhD studying. I wasn't even in the Salinas Valley. I was in Wisconsin, studying how Salmonella E. coli infects lettuce. It is actually not an infection because it's a human pathogen. It's not a plant pathogen. So they don't have the mechanism. The same way that if your dog is sick doesn't mean that you're gonna get sick or vice versa. So they are pathogens. This pathogen has specific mechanisms. But in the case of food safety or these human pathogens, this bacteria can survive, use the plants as a vehicle to get to the human. In this particular case, this virus is not gonna make you sick. The same way that when we were COVID, had COVID and you have plants at home, the plants didn't get sick with COVID.
So part of the process of not having enough food is that we need to educate the population to be able to eat things that are perfect.
Round of applause, right? Yes, absolutely.
So, you talked about the fact that they would till in the offset, per se, right, the harvest. But then there's weeds that you stated they live in throughout the non-growing season. How far away can these organisms fly or remove themselves and then come back into the field? What's their space of?
So that's a great question. So how far can they move it? So they move more some thread. So it's actually even more complicated. Once, imagine this is the mom thrips. And either one of these odd that there's a single thrips or two thrips. The same word for singular plural. So this is the mom thrips. She lays eggs on a plant. Those eggs hatch and the baby thrips don't have the virus. It's not passed from mom to the private. But when they hatch, if they feed on an infected plant, they acquire the virus for life. And whenever they go, they can actually transmit the virus. Those insects are not great flyers. But how many of you live in Salinas Valley area? Yeah? What is, whenever you're driving on one, what is often very common? The wind is so windy. If you have been in a field, it is incredibly windy. And especially because there are no trees, right? Everything is completely wide open. So those thrips, they don't even know where they're going. They just move with the wind current. So whenever they land, they have the ability to have a very wide host range. And so they end up landing in a host that most likely would be, in a plant that most likely would be a host of itself for the virus. Correct. Yeah, so we actually have a scientist at the UCA that is doing a very thorough study of this disease. In my lab, we're working with him on not only wide range, but we're actually In the next slide, I'll tell you what's happening. Yes.
Is the only solution to kill the thrips, or is there any like way you can inoculate the lettuce? Like lettuce doesn't have an immune system, right?
Hold on. So in addition to INSP, I know I'm late. I was given 20 minutes and I have something for like 45. So Pathology, well, there is another disease and the problem with this one, that this one does actually kill the plant. So what it does is, this is how plant, the lettuce plant, you see all these fruits, this is how the disease progresses. In which the plants start not only losing some of the foliage, but also losing their root system. And then when what happens is that the roots are completely rotted. When the roots are rotted, they cannot get water from from the soil. And it is even just more complicated because what happens when the plants are like look wilted? Yeah, nobody did, but also like if you see your plant at home that is wilting, what do you do immediately? Water them. So the growers start seeing their plants are wilting and they add a lot of more water. But guess what? This pathogen produces some spores that not only can survive in the soil for a very long time, but they have another type of spore that actually can swim in water. So the more water you add in the field, the more they can spread. They actually have literally a tail that they use to propel themselves and move through the water. So it is a really complicated situation because what happens is that INSP and Pithy and Will co-occur. So most of the time we see plants with INSP that the whole foliage is being impacted by INSP, and in the roots the plants have Pithy and Will. So the plants die regardless of whether it's one or two. You know, you get to a point that you can just not. There is no immune system that allows them to survive on that. But you would have to treat them separately because one is a pathogen that you need to treat with a fungicide. The other one is a disease that a virus, you cannot kill it, as we know with COVID, right? So the main way to control that disease would be killing the vector. So that would require massive applications of insecticides and fungicides to control this combo of diseases. So in addition to that, you know, there was flooding this year and a bunch of other stuff that resulted in that increase in the price. It wasn't just that it wasn't the Biden administration, it wasn't only inflation. There are actually, these are the things that our growers deal every day with, that we as consumers don't necessarily know and impact not only the supply, but also the price of our food.
Is there more fungicide? Because this is not fungus.
Pathology, well, it's actually, you should take my time going, you would have a whole semester to learn about this. So it's actually called water metabole. Is an organism that lives in the soil, is the same family than the Phytophthora pathogen, the potato family, is in the same group of pathogens that is causing certain oak death and all the issues in our natural forest ecosystem. And it's not a fungus, it's not classified in the fungi kingdom, but fungicides can be used because they are close related to fungi enough that they share some of the mechanisms that can be targeted by this virus. All right, so why do we need, okay, I hope that by now you get it, it's a big deal, right? Just pests and diseases. So why do we need to use pesticides? So just as a little bit of background, pesticides come from pestis, a plague or contagious agent, and side is the Latin word killer. So it's any product that is used actually to prevent, destroy, or repel any products. And how many of you buy organic produce? Okay, gonna open a can of worms that I'm happy to follow up at a later time, but there are actually synthetic pesticides and there are organic pesticides. Organic doesn't mean that it's pesticide free. It's only free of synthetic pesticides. And I'll give you an example of some organic pesticides. So the birth of the pesticide industry. So in back in the 1800s, we've been using different types of chemicals, and my colleague, Dr. Snort, is probably already thinking about all these chemical molecules that or chemical names that you're seeing here. But yes, people used to use cyanide to control pesticide. Carbon disulfide, which is used in the production of rubber, is quite toxic, and people actually used to use it for controlling diseases.
These two.
Even
These.
human urine or decomposing cadavers, that they would actually use exudates and stuff like that, thinking like, boy, if it's dead, it probably can heal something else, right? So they were the need for this kind of input this is a very unique case, because Bordeaux maize, there was a case of grape vineyards in the area of Bordeaux, France. And so they had some growers that started using copper sulfate as a way to actually, not as a pesticide, but they would spray it on the leaf because it has this very, like kind of like a teal color. So when they would spray the plants would look good. So the people walking by the vineyards would not spill the grapes because they have that cover. But then they actually start noticing that the plants that were sprayed were not being attacked by some of the diseases compared to the ones that were more in other areas of the vineyard and were not sprayed. And this is a product that we still use nowadays in organic agriculture. So if you think that plants that look blue are not healthy, some of the organic stuff you might probably have some of that because it's actually quite efficient. It is really good, not only because it can kill fungicide, it can kill fungus, but also bacteria, which is a very unique. We don't have a bactericide product, we have antibiotics. And there's a lot of controversy about also antibiotics and overuse of antibiotics in agriculture, which, by the way, when they talk about antibiotics in agriculture, they don't talking about crops, they're talking about animals, because we actually can only use one antibiotic in crops, and it's an antibiotic that we don't use for neither human or animal production. Yes.
To add to that, and tree crops like walnuts, up until about 5 years ago, they would spray the trees with that during the summer so that they wouldn't get sunburned.
Yeah, it has a quite unique benefits. But so going back into some of the bad guys that really have actually created this bad reputation for, and the reason why you're probably learning about this subject. So World War I, people started using chlorpyrifene is the commercial name. Is this long chemistry name? It's a product that actually makes people cry. And if you, the main reason why is also a respiratory irritant. And the main reason why they were spraying this, what is called tear gas. And so why they were spraying tear gas was because it didn't kill the soldiers, but it forced them to actually have to take their helmets or their masks off. And that was used as a point of, benefit for the attack. But after the war, there was a surplus that they didn't use. And they said, well, where can we use it? Well, let's put it in ag. I mean, if it can make people, it can cause diseases on humans. They are nematodes. They are tiny little worms that live in the soil and kill plants, but they actually eat the animal kingdom. So they have a system. They share a lot of the same mechanisms that so they and nowadays it's one of those products when you see strawberry fields are often covered in plastic, it's because they fumigate and they actually use some of this tear gas type of gases that they actually spray the soils with. They have to tarp them so that the volatiles don't leave the soil. And while they are trapped under that plastic, they kill a lot of different stuff, whether it's animals, pathogens, or even weeds. The other example is DDT. You probably have heard of that product in the past. was an insecticide that again was used to develop for actually use in during World War II, because one of the main reasons of soldiers were dying in battle, not necessarily in the battle, but actually because of the diseases that they were encountering, and particularly mosquito transmitted diseases. So they were actually spraying the fields that were gonna send their soldiers with DDT. Again, after the war ended, there was a surplus. Well, if it kills mosquitoes, maybe it would kill these other things. And they started using it in agriculture to kill pests. And even cat lice, as you can see there. That is actually, that is somebody being sprayed with DDT in the, that is, but you know, like, this looks shocking, right? But we also used to smoke in airplanes and in banks and schools, right? We didn't know back then that this was actually, could have a negative effect on human health.
Zero.
I grew up in Gitmo in the '70s, and we used to have the trucks come through and spray the DDT. And I remember as a kid, it was just so much fun to run through the truck.
And
Yeah.
because of that, oh, yes, sir. Sir, can you speak up?
A friend of mine who works at the Monterey Revolution told me that when they do core samples out in the day, they find DDT down there. It's so stable that it never leaves the.
Yeah.
And they can literally date their core samples to within a couple of years just by finding the DDT.
Correct, correct. Which actually, so you see it here on the slide. It was such a powerful toxin, but also long lasting. So they could actually go spray those fields. They went in during combat. It's not like they could always go and spray the field before sending their troops, right? So that characteristic of the chemistry was intentionally selected for.
I just want to say one point that although DDT was banned in the United States, and I'll talk about that in a second, in 1972, it is still widely used in sub-Saharan Africa.
Correct.
For public health purposes, so it is still used.
Yeah, for malaria control particularly.
And dengue too.
Yeah. So we're not gonna go into the details because again, I'm over time, but many of you know about this book, but in the book, this is the issues that Richard Carson highlighted in this book were exactly related to that long-lasting characteristic of the chemistry. They were seeing an issue with the loss of the bald eagle, not because they were spraying the eagles, but because the eagles were dying after consuming fish that have been in water where the residues of the product ended up reaching. So they lost these multiple steps in the food chain, and it still made it to the bald eagle. And this book really was revolutionary because now it informed the establishment of the EPA, or the Environmental Protection Agency, that actually works very closely nowadays with the USDA and the state governments. In our case, the California Department of Food and Agriculture and the California Department of Pesticide and Regulations, in actually making sure that the food that we produce is safe, but also that we do not overuse this type of products. There also have been a lot of advances in the use of pesticides, not only in implementing technology and machines, but also now we don't even have to spray crops. You could actually patch your seed with different pesticides. And what is the good part of that is that if you actually provide those pesticides early on, they degrade, their time of degradation is much longer than if you spray a mature plant that is close to harvest. Right, so by the time that the full harvest is ready, some of these products are completely degraded in the environment. We now use drones and even robots that are still spraying the same products, but help in reduce the risk of human applicators that used to. We have this is an example of how you should do it, but we probably all have seen examples of people doing it the wrong way. And now going back to the example or what was mentioned about the immune system, now we even have examples when we have we're using biotechnology approaches to generate crops that actually have the equivalent of vaccines. So papaya ring spot virus, that virus that I show you with the ring spots that in Hawaii is the first example of a plant vaccine approach in which they actually took a section of the genome of the virus, introduced it into the plant, so the plant recognizes and fights that virus. The same way that when you get the COVID vaccine, you're not getting the actual virus, you're getting a portion of the genome of the virus, so your plant, your immune system targets it every time that it finds it. So we now have this kind of approaches used in agriculture as well. Yes.
All right, just a quick question about the technology. I work in San Lucas in South County, and they've got tractors out there that shoot laser beams that are killing weeds. Is there research being done to apply that technology to insects?
Yes, so in this particular case, this is for viruses. There are other cases when, for example, with lettuce, one of the main questions is, well, should we actually, rather than rely on insecticides to kill the vector, rather than rely on fungicides to kill it well, can we actually change the genome of the plant to not being susceptible? And that doesn't mean a transgenic approach when you're introducing something from a different organism, but you can actually go and edit the gene of the plant and just find what are for example, the fragment of the genome that the virus or the insect recognizes that the plant, because they chew on lettuce, but they might not chew on, some, like almonds, for example. So what is on lettuce that is attracting the plant? Or is they're producing this type of volatile? Well, can we actually suppress that volatile so the insects don't find it? So using that kind of like more advanced approaches, again, it's not a transgenic because you're not introducing genes from a different organism. You're actually just looking at the whole library of genes that the plant has and create and deciding whether you want to delete or modify some of the already existing genes, which is also FYI used in human health for example, in cases of genetically transmitted or passed or triggered diseases like Alzheimer's. So now we know what are the genes that are associated with Alzheimer's, and you could even think about, well, you could actually go and change the genome of humans to not have that gene, right? Is that ethical? That's a conversation or topic for another time, but we do have the tools now that we can actually implement in agriculture. CRISPR has been used in lettuce, but not in commercial lettuce, only for research purposes. They have been shown to be effective. They just have not been approved. And there is the industry, particularly in the lettuce industry, none of the growers here want CRISPR. Not because they don't believe in the technology, but because they fear that the public is gonna correct. Same with bananas, same with all these crops that again we consider very staple crops in our diet. None of them are being modified with CRISPR. So we have now mushrooms. Many of you eat butter mushrooms, right? So one of the issues with butter mushrooms, especially think about the weather. What happens if you don't cook them right away? They start turning brown, right? What happens with oranges when how many of you have kids? Do you send slices of apples to your kid? They turn brown. They are not less healthy, they're not less nutritious, they turn brown. And why they turn brown? Because once you cut the apple, it starts oxidizing. So now we actually can use CRISPR, which is a technology where you can change the genome of the organism and actually get rid of the enzyme that makes the apples oxidize, so the apples don't turn brown. Do you feel less scared of that one versus the a lettuce resistant to insect or a human that doesn't get Alzheimer's, right? It's the exact same technology, but different applications. We have crops that have been modified with CRISPR, and they are in the pipeline of being actually released. There is one of the latest one is a tomato that has, that their genome was modified to actually produce capsaicin, which is the spiciness of the peppers. So you have a tomato that is actually spicy.
Oh, yummy salsa.
Correct. So that is like you caught the middleman. Now you could just make the spices. So these technologies are being used, but they're not used broadly across all the crops in all the industries. So just the last thing I want to share is that even, yes, pesticides could be bad. They can be really bad, and they have there are a lot of social and economical implications of using pesticides. But there's also have been a lot of efforts that have gone towards making the use of pesticides more safe, including integrated pest management. So which means that you actually use pesticides only when they are needed, not in a calendar base. This is not like you take ibuprofen when you have a headache, right? You don't take it every day at 8 a.m. Maybe you do. That's different. So how about we go to use these approaches? We make sure that we identify and monitor the pests. We're not killing every single insect. We're only attacking the bad ones, the ones that have a direct impact. And we only do it when we cross a threshold that is really bad. When we cross that line, that after that point, we know that the whole crop is gonna die or the farmer is not gonna make any income. We don't do it here when you only have, you spot a couple of insects in the field. And then before, even when you get to that point, by then you have also already integrated other approaches that are not chemical. So we are not only relying on the chemical pesticides. So this is just my last slide showing you this triangle that shows this is what is being promoted. And in California, this is a big deal because actually growers get, there's not only a requirement, they get incentives if they can demonstrate that they are implementing integrated pest management approaches, which again leaves like you have to go through all this stuff before they can get to the pesticide application. But the public thinks that it's the opposite. The public thinks that the grower would first go here because that is what we are often told. But pesticides are not only a pain to apply and use, they're also quite expensive. So it is a misconception that a grower would always go first to a pesticide approach. But if their decision is save the crop or apply a pesticide, they definitely would apply a pesticide because their whole life and the life of many people depend on that crop. And if they don't, so often if they don't apply the pesticide, they lose everything. Again, I'm not speaking today on behalf of any chemical companies. I'm not, I don't have any stocks in any of those companies. And I'm not promoting the use, but I hope that this talk was helpful in at least demystifying some of the misconceptions about the need of pesticides. So remember that we use them because their plants get sick and they are attacked by these pests. Those attacks affect the food production, but also the environment, but also the sustainability. They have, of course, social implication and cultural implications. And pesticides, just like our medicines, we have to use the same kind of thinking when we use pesticides and when we use a medicine. It's not good to overuse a medicine, right? There are issues when people start overusing certain types of medicines, right? And we have epidemics of people that are suffering from overusing some types of product. The same that when you overuse pesticides could also lead to problems. But when there are times when you absolutely need to use them, and if you use them in the safe way, they could actually be quite beneficial. So I'm gonna leave you with that. Thank you again for your attention, for all the awesome participation. You participating in this time more than even my students. I hope to. I wish I could see you in my class on a regular basis. Thank you. Yes.
Something I've heard of the past couple years is like the world is running out of chocolate, that's a big problem. Oh, no.
Can you speak a little louder?
Something I've heard is like the world is running out of chocolate,
Oh.
so they want the crops. How worried would you be?
If chocolate is in that slide, let me tell you. Yeah, cocoa is it. So this is only one thing. So the problem with cocoa is also that it's a crop that is only grown in certain areas. And that is again, that opens a discussion for there's a lot of social impacts that these diseases have in the location where we grow certain crops and how in developed countries all the favorite thing of a developed country is go tell a developing country what to do, right? Because that what we want to save cocoa, we want to save coffee, but without actually thinking of the implications that those decisions, those mandates have on the local community. Cocoa is a crop that it's actually a tree, it's not a herbaceous plant. So it is really hard to not to grow, but to breed. So there is not many varieties, just like the banana. They're very limited with the kind of stuff, the genetic variation that they have. And on top of that, we grow cocoa cacao in the tropics, with weather is super conducive for pests and disease. Yeah, so I think you will be good for the next few Halloweens, but yeah, keep that in mind. Yes.
So I'm not gonna ask this right, but I hope you understand how I'm gonna ask this.
Chicken
Going back to the apple, it's current. So I cut my apple, it turns brown, yada yada. What's the advantage to the apple to having that makes it turn brown? That's one question. So if we edit it out, does that long term? And then the second is those organisms, and I'm not afraid of this, by the way, I'm just. When we do that type of editing, do we also make them sterile so they can't cross? Can I ask those right?
Yes, those are actually excellent questions. So the first one, why do the apples turn brown?
What?
I mean, it's the same with the tubers, right? With the potatoes. And it's been a huge deal. So if ever any of you have a chance to make French fries from scratch, that you cut them, you haven't even finished cutting all your potatoes when the first ones are already brown. And it's a huge problem because actually some of those enzymes in the potato French fry production, the browning gets worsened when you actually dip them in the oil. So there has been a lot of work that has been done in the past to try to select varieties that produce less of those enzymes related to those oxidation processes. In the particular case of fruits, think about apples or like true fruits. So fruits that the definition of a fruit is an organ that actually have seeds, and the seeds are the reproducive the way to reproduce and pass their genetic material. Right? So when fruits fall from the tree, do they fall right away as soon as they start growing? No? They usually fall later, right? And they fall when they're green or when they're more ripened? Overly ripe, right? Because their idea is that by the time that they fall off the tree, they fall on the ground, they splash those seeds. There are no physical barriers for those seeds to escape. Because if you think about it, if you are an apple tree and all your baby seeds fall around you, those will become competitors of you. Right, so you want also the fruits need to be ripened to have colors and smells and flavors that would attract birds, squirrels, other stuff that are going to distribute those seeds. So the oxidation enzyme is part of degrading the pulp of the fruit. But of course, when we grow food, we're not thinking about how to persevere or make sure that the apple survives for the rest of eternity. It's like, how can my child eat the canned apples, right? And not not bring them back at home every day. But if you go, so and there are tricks, right? I mean, you know that you can put lemon juice, but you probably, have you tried it with your kids? Some don't, some can pick it. But you know, like there's McDonald's, when you buy a Happy Meal, they already have the sliced apples that have been treated with other products that prevent them from turning brown. The second question is like, do we change other stuff? These approaches are so unique that is so precise that you can actually determine what you change at the gene level. So this would be the equivalent, imagine if our entire genome, which might be a word that you have heard of, but if the genomes are all the genetic material that we have. So imagine it's like your library at home. You have, within your library, you have hundreds, thousands of books perhaps, depending on how good of a reader you are. But within the book, you also have chapters. And within the chapter, you have words. And within words, you have specific letters. This is at the level of changing single letters in a word in an entire book. Is that so it's like you use literally like a word editor tool, but you can just go and say, find words. Sometimes those things that we're dealing with is because of mutation. So if they go and find the word that is misspelled and fix it. Sometimes by fixing those misspelled words, which is in the case, for example, of Alzheimer's, go back, fix those mutations and don't have the outcome of that. It's quite precise, and then in the majority of cases, we are getting better and better using computational approaches and biotechnology approaches. We are getting very, very good at reducing the downfall or potential downstream consequences. Corinne, you're gonna give it a shot?
Thank you so much. I know there are like 2 more questions, so Margarita and then.
I have time, but I know that I already overextended the invitation. Like I guess, when you buy for dinner and I stay for coffee, drinks, and you're preparing the room for me now.
We love having you.
Alright, my question is back to your PhD research, and basically what I wanna know is if you, and I've asked this to some other people we talked to, but if you have like triple washed lettuce, do you personally rewash it or do you eat it right out of the package?
How much do you wanna know? Or like, you know, like sometimes truth, sometimes you don't wanna learn the truth, right?
Well, I personally like to wash
Mhm.
anything that I get that says it's already washed, and
Yeah.
my partner says, oh, it's already washed.
Yeah.
And I'm like, no, so.
So what I can tell you is based on our research. I'm not saying that every single, it would always be the case in your household. Because also you can imagine, so these are bacteria that colonize, they are not infected, they're not making the plant sick, but they can start growing on top of plants. And of course, the growth of a bacteria on a plant and the efficacy of getting rid of it will depend on how long has the bacteria been there and how much of the bacteria is in there. In our research that we did, it didn't matter if you wash it. It doesn't matter if you wash it, because the bacteria, even though it's not infecting the plant, it has molecular approaches that it uses to actually attach in a way that it doesn't go away by washing.
But wait, so are you saying even if you get the triple washed and then you wash it, put it in your lettuce spinner, it's still in there?
For certain bacteria, it's
Okay,
not
never
for
mind, I
all.
don't wanna know.
So for the human pathogen, of course, you're getting rid of a bunch of other stuff, so it's always safe to wash your things, right? Because it might have not only the human bacterial pathogens, the enteric pathogens like Salmonella, E. coli, but it could have some other stuff in there. It could even have COVID. It could have the norovirus, which are the majority of the time when you get food poisoning, it's not even E. coli or Salmonella. Is when you eat something that gets you sick within 24 hours is a virus. Bacteria would need more time. So bacteria usually need at least 72 hours. And you would actually, it's not only diarrhea, it's not only vomiting, but you actually need to experience fever. The problem with those bacteria is that some of the strains, will send you to the bathroom, will give you a fever, you would lose a couple pounds. Might not be the worst thing, but the problem is that there's some strains that actually, not all of them, but some strains actually could be quite bad that can actually lead to kidney failure and actually can produce some toxins that can actually kill you. So it's not one of those that they're all the same. It depends on what you have. So it's always better to wash them, but there are in some cases when washing is not enough. The only thing that is enough is cooking. So there is actually a great amount of evidence. A great amount of evidence that Asian cultures have less issues with food safety than Western cultures. And if you go to an Asian restaurant, you often see that they stir fry their vegetables. That cooking process is the best. Actually, to get rid 100% or to a larger number of microbes, not necessarily the wash.
So the answer to the question is you don't have to wash the fourth time.
I would say wash it as much as it makes you feel comfortable, but by washing it, you might still, there are times when it's not enough. It's like washing your hands, right? We were washing our hands using masks and still we got sick during COVID, right? Many of us. So sometimes it's completely out of control.
So the two questions that I get asked are about, does vinegar kill it, the things that you're talking about? And the second thing is that people want to buy the Trader Joe's special vegetable cleaner. Is that any better?
So what in our research, what we found is, again, it's not 100% effective, but what is actually the most effective against bacteria? So bacteria have the capacity to produce something called biofilms, which is like this. They start, even though bacteria are very tiny, they start actually growing together. Every bacteria, so every single bacterial cell, when it reproduces, turns into two turns into four into eight, so forth. So they produce these very large communities, and when they are growing together, they grow as a community and form this biofilm, almost like barriers. So when they are so packedly tight, growing together, it reduces the effectiveness of this product. Bleach is the best. But even in our research, what we found is that it's not just like any concentration of bleach. It has to be a concentration of bleach that you would probably not want to eat or consume.
Yes, I remember a while back when I was still in school, they were using ultraviolet radiation to sanitize some of the products.
So sanitizing,
like lettuce and all that. And as far as I remember, the radiation did not affect the quality of the fruit.
correct.
But people got scared because they thought they were gonna go read eyes.
I mean, that is the risk, because especially for those companies that offer the triple wash and our industry really is at the forefront of developing those technologies. And many of other industries actually are trying to learn from what the Salinas Valley leafy greens industry is doing, implemented in other systems. Because you don't only get sick with E. coli or Salmonella from eating lettuce. And you can get it from a bunch of other stuff. If you look at the CDC website, CDC became famous because of COVID, but actually they have all the reports every time that there is an outbreak of foodborne illness, whether it was pig feed or mushrooms or papayas or mangoes or that. So they report it all the time, because every time that so many of us have had food poisoning and we don't go to the doctor. These are cases that are unreported, but whenever you go to the doctor and they actually treat you for food poisoning, they actually have to report it to the CDC and said, there was a case of this person ate tomatoes, because there might be somebody else that comes with, oh, I also ate tomatoes. So I also ate tomatoes. So they start building the case and tracing back, that's how they end up coming, saying, oh, it was tomatoes from Taco Bell, or if you bought lettuce from the Salinas Valley in this period of time, then get rid of it. That is the traceability piece. For the sterilization, there are also some non-chemical approaches that are being used now. Temperature, radiation, but of course, that is again is kind of like a great zone, because the companies cannot go too much into ensuring that it's 100% micro-free if it's going to affect the quality or the appearance of the food or the shelf life. They're also trying to use some products that extend the shelf life but reduces so it's like a Swiss watch. So, like so many tiny little pieces that every time that you change one, it affects the other. That's why again, like they tell my students, I'm trying to convince them to go into ag. But it is food production is not easy. Not only you have to deal with everything that's trying to kill you in the field, you get paid less than nothing, and because you saw the example with Cardi B, right? So lettuce was so expensive. But on top of that, you made it, you harvested, and on top of that, now you have to extend the shelf life. You have to make sure that they look fine, and all the safety and nutritious aspects. So only the best can go into ag. Any more questions?
Thank you, Jake.
All right. Thank you.